guys, welcome back. We are going to talk about misleading graphs and statistics today. Now, I know some of you all the time are like, Miss Oz, when am I ever going to use this in life? This chapter, this section is your section because this is something you'll use all the time. You will have graphs and charts and statistics put in your face constantly, especially during this time we're in now. And being able to decide, is this a legitimate statistic? Is it worth me looking into? Can help you. So we're going to look at a couple different graphs and decide what might be wrong with them, why might it be hard to believe what it's saying or to believe what it's saying, and we'll go from there, okay? So I'm actually going to start with this part B question. So we have a graph here. We have the effective fertilizer. We have plant A, B, C, and D with different, I'm sorry, it's not plant A, B, C, and D. It's fertilizer A, B, C, and D. And I'm looking at these plants, and right now, I'm definitely going to go with plant or fertilizer D, right? It's clearly taller than all the other ones. It seems like it's making a better, fuller plant. And that's just what I want to go with, right? But if I'm looking at this graph, so what people might believe is fertilizer D is best, okay? So I want to spend my money on it. But when you're looking at this, a graph, okay, first off, you want to make sure that all of your x-axis things are marked properly. So A, B, C, and D, they're far enough away. They're not numbers, so we don't have to worry about them jumping, okay? You want to make sure the pictures are kind of the same. So really, these pictures should all look exactly the same. And they should actually be pictures of the exact same size. Like if I had a square stacked up against each other. So maybe this would be 2 squares or 3 squares. This would be 2 squares. This would be 1 square. And this would be 2 squares again. Okay. And maybe there's a plant inside of those squares. But we want those pictures to look the same. That's not really the big issue here, though, with our graph. The big issue here is if we look at the y-axis, okay, it's counting 80, 81, 82, 83, 84, 85, 86. But it is not starting from 0, and it did not tell us that it wasn't starting from 0. Okay, our graph did not start at 0. So if you really think about this, between 83.4 and 85.2, so 85.2 minus 83.4, if I borrow here, that is only, I'm sorry, that's a 4. There's only a 1.8 gram difference. That is not a very large difference. So if I had actually started counting at 0, or maybe even counted by 5s, these two plants would have been much closer together, okay? And then I might have been like, well, maybe I don't, C and D are pretty much the same, okay? Now, let's think about this. This isn't a specific question, but it's good to think of. Why would someone put this graph out here, this chart out here? Well, they obviously want me to buy fertilizer D. So this is probably made by the company of fertilizer D, okay? And maybe their fertilizer's a little bit more expensive, but they're hoping you'll buy that one, right? So they're saying it's the best, so it's worth those couple extra dollars you have to spend per bag or whatever. Whereas fertilizer C works pretty much just as well. Oops, sorry guys. And maybe it's a little bit cheaper, so they don't want you to go buy C or A or B, okay? So we have to make sure we're looking at the graphs. Are they giving us appropriate information, or are they trying to trick me into believing that one product is better over another, or one country is doing better than another country, right? Or maybe unemployment stats, whatever the chart is trying to tell you. Looking at that data and making sure, okay, is every number here represented? Is it an even scale? And does it start at 0? Because they're trying to make this gap look much bigger than it actually is, okay? We're going to look at average gas prices in September here. So in 1993, we had $1.08 per gallon. 1995, $1.10. 1997, it looks like we have a big jump here to $1.24. And then we have $1.26 and then $1.43. So what might someone believe from this graph? It might be that we have a very large jump here from 1995 to 1997. What's going on? Why did gas jump that much? So what I might believe from this graph is from 95 to 97, we had a large upcharge, okay? Or a large amount of gas prices going up, okay? But we want to look at this again. So this is a line graph, so there's a line, and that's fine. They're showing me my points. Next, I want to check my x-axis. So 93 to 95 is 2, 95 to 97 is 2, we got 2, and then 2, right? So all of those were 2 jumps, so that's good. Nice range here. We're going to look again here. So we have here a 10-cent jump. Okay, that's no big deal there. Then I have a 2-cent jump, and then another 2, and then another 2. Oh, and then another 2, and now I have a 20 and another 20-cent jump. Very, very different all the way through. So they're trying to trick me, okay? They're trying to say, hey, look at this. So from 95 to 97, we only have a 14-cent jump. And then we have a 2-cent jump. Okay? And then from 26 to 43, that is going to be, if I think of I better do it off to the side, otherwise I'm going to get it wrong here. We have a 13 minus 6 is 7. We have a 17-cent jump. So really what we need to see is that the biggest jump was from 99 to 2001, okay? It's only a 3% or 3-cent difference, but according to the graph, if you look at it, this jump looks much bigger than this jump. So someone is making me believe, oh, that person from 95 to 97, we had a huge gas jump, okay? So why is this graph misleading? The intervals are not the same. Okay, we talked about this with our frequency table in 2 sections ago, I believe. We want those intervals to be the same. So again, looking at this, why might someone choose to show me this graph? Okay, so maybe they're talking oil prices and saying, look, we had this big jump back in 95, 97, but now we're holding steady. Maybe it's a president saying, hey, my predecessor from 95 to 97, there was this huge gas jump, and look, since I've been president, we've been slow, smooth, and steady, right? We've gone up a little bit, but that's normal, that kind of stuff. So you want to make sure when someone is telling you a statistic, does it actually make sense? Do your own research, because this is not the only chart out there. You can look and be like, oh, from 95 to 97, what were the average gas price, okay, in that September of that year? And actually calculating it out a little bit. What is this change here and this change? What, as you know, is your slope, right? Does it make sense for those things to be happening? So really, really looking at things and making sure they make sense helps a lot with the graph, and that's a good life skill to have. Last one here. Why is this graph misleading? Go ahead and pause the video and see if you can look at this graph and decide why you think it's misleading. Okay? And this graph, if we know, we have 5%, 10%, 20% of people, which adds up to about 35%. This is not 100%. I'm going to write this in a different color so we can see it a little bit better. Pie charts need to add up to 100%. Okay? If they don't add up to 100%, they need some sort of other category here telling me what they are. Okay? Otherwise, it just doesn't work. It doesn't show anything. So right now, I'm thinking that Smith is going to win, right? Because this is for a student council election. But there's a good chance, because this only adds up to 35%, there is a 65% chance that some other random person's going to win. Or they haven't polled everybody yet, okay? So there's a good chance Smith is not going to win, okay? This would be very important in something like a presidential election, right? If you don't have 100% showing for your random sample, then you can't be sure who's going to win. And I lied, there's another problem. So, as a research surveys people leaving a basketball game about what they like to watch on TV, explain why the following statement is misleading. 80% of people like to watch sports on TV. Why do you think this might be misleading? Well, I'm going to say people leaving a sporting arena probably enjoy watching sports already. Okay? So, this is a bad sample, okay? This is what we call, this is not a random sample. Okay? So a better sample to take would be maybe looking at a school, okay, and picking students from every type of elective, right, and saying, what kind of things do you like to watch on TV? Because if you take things from sporting people, they'll probably still say sports. But if you take things from like a journalism, maybe they like to just watch really good movies. There goes my pen. Maybe